Live. Here we go. We are live. Okay, number one. I think first of all, review day. It is 5/30/19. I always like the date. So if I graph it, I think this is the easiest way to do it because if I can see it quite often, I can do it right. Endpoints of diameter. Let's see if we can put this on a piece of graph paper. So if I go to 1, 2, 3, 4, 5, 6. And negative 5, 0. 1, 2, 3, 4, 5. Okay? And again, I'll probably draw an egg. It doesn't have to be perfect because what we're looking for obviously is going to be the center and the radius, right? So the center shouldn't be too bad because, you know, if that's the diameter, then the center's got to be right there. Okay, how did I get that? Well, you can count. I mean, I just found. I could see it. But if you can't see, you can just count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 and 6, right? Which means 3 and 3. Okay, so that's got to be the center. All right. So if the center of this is at negative 2, 3. Then I can set up at least part of the equation like this. I go, okay, I can have a x plus 2 squared plus a y minus 3 squared equals r squared. Okay? And again, if you missed yesterday, I wish, bummer that you had, but it's really not that bad. Again, if it's, remember the silly little dance. I did this yesterday. Remember my silly little dance? Remember? 5. It's on the inside.
You didn't.
So
I don't think you did that.
Okay, well, I'll do the silly little dance.
Yeah.
Which way am I going?
You're going right. Positive.
Right? But it's the opposite, right?
It's in the parentheses.
It's in the opposite. It's the opposite. Totally right. Good job, Gavin. So instead of negative 2, it's positive 2. Instead of 3, it's negative 3, right? Thumbs up on that? Okay. Now, to get the radius, let's pick one of these 2 points, doesn't really matter which one, and plug it in for x, y. So the easiest one for me to pick, actually, we'll take 1, 6. So 1 is an x, 6 is a y value, right? And I'll just plug it in and it'll solve. So, okay, I can do that. So I'll go parentheses. Instead of writing x, I'll write 1. So I'll go 1 plus 2 squared plus... Instead of writing y, I'll write 6. 6 minus 3 squared equals r squared. And then it's pretty easy because r squared is going to happen for me, right? Just solve. So I'll get 3 squared. I'll get another 3 squared equals r squared, right? So I get 9 plus 9 equals r squared, or 18 equals r squared. Now you don't really need to square root it. You can, but what you want to do in the formula is just r squared, which is 18. Yeah, Gavin? Okay, great question. So you're with me to the formula, right? You agree with the formula? You agree with this part of the formula? Huh?
How exactly did you get that?
Okay, so the equation of the circle is x minus h squared plus y minus k squared equals r squared, okay? That's the standard form of a circle, right? Were you here yesterday?
Yes.
Okay, it's all right. We'll go back through it. It's no big deal. So that's the standard form of a circle. H and K are the center of the circle, which we found to be at negative 2 and 3. So we put the negative 2 into here. Negative 2 is a 2, right? And we put the 3 right there, okay? So then, to find the radius, right? To find the radius, one, you could do Pythagoras theorem. Actually, that is one method, is Pythagoras theorem. That'll work. Or take a point, plug in it for the x value, take a point, plug it in for the y value, and solve for r. So it took 1 or 2, and both points would work. Either point would work. I just chose the 1, 6, because then I wouldn't have negatives to deal with, right? So my answer, then, I know r squared is x, so I'm x plus 2 squared plus a y minus 3 squared equals 18, and that's the equation of that circle. Okay? Thumbs up? All right, let's move on to number 2. Okay, number 2. We're going to write the circle in standard form. Okay, so we've practiced this a couple of times. Let's practice it again. So number 2, I've got x squared plus y squared minus 10x plus 4y plus 13 equals 0. Okay? So what I really eventually want to do is factor. I want to factor, right? So let's get the x's together and the y's together. So I'm going to rewrite it. X squared plus 10x, and I'm going to leave a little spot. I'm going to leave a little space here, okay? And Evan, I think you see why a little space. When you're doing your problem, it's nice to have a little space there, isn't it? Yeah. Plus, I'm going to go my y squared plus my 4y, and again, I'm going to leave a little space, equals negative 13, okay? So grouped them, x's with x's, y's with y's, and I brought over the 13. Okay, now, we'll do this half of b. So, we're going to take half of negative 10, which is negative 5, and negative 5 squared is a positive 25, okay? We'll take half of the 4, which is 2, and we'll square that, and we'll get 4, so add 4. So you take half of b, okay? Jace, give me your phone, please. Thank you, man. All right. Golly, a lucky day. Look at that. Woo! Gold mine. So then, but you got to balance. So you can't just add 25 and add 4. If it's a scale, you're off balance, right? So you have to balance the equation because you have an equal sign. It won't be equal unless you balance it, right? So plus 25 and plus 4, and then let's see what we get. So this will factor. I sure can. Thank you. This will factor. It'll factor into an x minus 5 times an x minus 5, right? Multiples 25, that up to negative 10. This will factor into a y plus 2, and let's see, what does that add up to? Is that 9? I think it's 9. Is it 16? Oh man, I'm glad I didn't put down 9, huh? Yeah. Thank you, Johanna. Equals 16. Okay, so then x minus 5 can be rewritten as an x minus 5 quantity squared. And a y plus 2 can be rewritten as a y plus 2 quantity squared equals 16, right? Now graphing, it's easy. My center is at positive 5, negative 2, opposite, right? Opposite. And my radius is the square root of 16, which is 4. Okay. All right, let me get out my graph paper. So I've got the equation, because I'm going to ask for that tomorrow. And now let's graph it, okay? So to graph it, I'm going to go ahead and hopefully not make a bad looking egg, right? I'm going to go to center of 5, negative 2, and the radius of 4. So I'm going to find my center, and I'm going to go 4 out, 4 back, 4 up, 4 down, and draw in my circle, okay? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to draw it in the best I can. How's that? Thumbs up? Okay. All right, number 3. Am I going too fast? Okay, I'll wait for you. All right. Let me draw this out. Okay, 3. A, B, C. I've got 44. I've got 15. I've got 19. Okay? All right. You've got your notes in front of you. Remember our really good notes? Remember these awesome notes? Remember these awesome notes? You guys have your notes in front of you? Okay. So when you look at this problem, what do you see? What do you see? Opposites. Cole's totally right. We've got a pair of opposites. You guys see that? So we have a pair of opposites. Angle A, and 15, right? What else do you see?
19.
Right, so the 19. So if you've got the 19, you can find its opposite angle, okay? So if you look at our notes, it says to find an angle. We're just going to set it up by putting the angles on top. So, all right, I can do that. I'm going to use this one right here. So I'm going to go sine of C over its opposite side equals sine of 44 over its opposite side, right? Multiply up to 19. Sine of C equals 19 times the sine of 44 over 15. Found a calculator, Callan. Don't have to steal yours. 19 times the sine of 44. Be careful to close your parentheses, you guys, because if you don't close your parentheses, sometimes you'll get something totally different, right? Divided by 15, and I get an answer of about point, but I expected that because I'm going to do the sine inverse of that, right? So we're going to go sine inverse of that answer, because we're looking for the angle. So I'm going to go sine inverse of that answer, about 61.6 degrees, okay? How am I doing? Okay, now, angle B should be easy, right? How many degrees are in a triangle? So we're going to go the measure of angle B is equal to 180 minus parentheses 44 plus 61.6 degrees, and I'll get that one, 180. Did you get it already? You are way faster than me. Thanks, Daisy. 74.4. Joanna, thank you, Joanna. And then finally, we got to find little b, side B, right? And again, we have opposites, right? We've got our opposites. I'm going to stick with the 15 and the 44 because those are exact numbers. These are kind of like calculator numbers, so I'm going to stick with this. So if I want to find little b, I'm going to go little b over the sine of 74.4 equals 15 over the sine of 44, right? And I'll cross multiply that up there. How am I doing, okay? Close my parentheses. Divided by sine of 44. And you do not need to do an inverse because you're not finding an angle, right? You will not use the inverse button. You're just going to, boom, there's my answer. About 20.8. How's that? 2 thumbs up, 1 thumb up, sideways. Okay, good. Yeah, I don't think you'll find trigonometry is actually pretty easy. You think a word like trigonometry has got to be hard. Nah, it's not. It's pretty easy. Functions, right? It's the F words. It's always the F words. Functions, factoring, fractions. Yeah, I know. Okay, you guys ready for number 4? Okay, flip the page. Let's take a look at number 4, okay? Let's see what we got. Okay, so number 4. Oh, find the area of triangle ABC. So, hold on, I'm going to go back. The area of this triangle. So the area, right? So we've got an area formula, 1/2 adjacent, oops. Area 1/2 adjacent sine of theta. So to get the area of this thing, I'm just going to go 1/2. And I'll use the, I may as well use the 19 to the 15, right? So go 1/2 19 times my 15 times my sine of the angle, and the angle in between, the inclusive angle is 74.4. It's the angle in between. Does that make sense? Use this formula. It's got to be the angle in between the two sides you use, 74.4. I'm just going to use my calculator. 0.5 times 19 times 15 times the sine of 74.4, and I get an answer of about 137.25. Centimeters squared. Thumbs up. Okay, cool. Okay, let's move on to number 5. They swept this way too quickly.
It was 137.
137.28. Yes.
Okay, so we used 19 and 20.8 and 44, and we got 147.26.
Sure. Yeah.
So on like a test, if it's really close to that.
Oh, of course you'll get it. Absolutely. So it's a matter of rounding, right? I always say round to the nearest tenth if you can. Don't worry about it. Yeah. Yeah. You can't be that accurate. I mean, it's impossible, right? Well, it's not impossible, but yeah. You're fine. Okay, let's look at number 5 now. Okay, number 5, redo 4, 5. Okay. And I've got X, Y, Z, 18, 20, and 21. Okay, now, what do you know? What do you know? Side, 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 right? So what do you want to find? What do you want to find? I got side, side, side. What do we want to find? An angle. An opposite angle. Now, here's a suggestion, and you may or may not know this from the unit circle, but go for the obtuse, go for the biggest angle first. Okay, go for the biggest angle. And we're not in pre-calc, but we will learn that sine inverse will get us up to 90. Cosine inverse can get us more than 90. Okay, does that make sense? And it comes from the unit circle, right? Yeah, Daisy?
What if you don't go for the biggest angle first?
You could end up with, remember how we do the double triangle? Remember how we do the double triangle, right? Now, we'll do that too. You could find its supplement, and then what you'd have to do is subtract from 180, okay? Okay, so I'm going to go for angle Y. It's got to be the biggest angle because it's opposite the biggest side, right? So let's go for cosine of Y equals parentheses. Adjacent squared plus adjacent squared minus opposite squared parentheses divided by parentheses 2 times my adjacent times my adjacent. Okay? So I've got cosine Y equals parentheses 20 squared plus 18 squared minus 21 squared divided by parentheses 2 times 20 times 18. Okay, I'm going to use my calculator real quickly. I'm just going to go parentheses 20 squared plus 18 squared minus 21 squared parentheses divided by parentheses 2 times 20 times 18, and I will get a decimal. Kind of anticipated that because I'm going to go cosine inverse of that, right? So I'll go cosine inverse of that answer, and let's see what I get. Cosine inverse of that answer, and I get an answer of about, oops, delete that, and I get an answer of about 66.8586, 66.86, but nearest tenth, how about 66.9 degrees, okay? And actually, there's a point where I round to the nearest tenth, so I've already lost some accuracy, right? But it's going to be good enough for what I want, okay? So if I put the 66.9 degrees here, now, you could do the law of cosines again. You can. But I have a pair of opposites, right? So the law of cosines, yes, will indeed work, but the law of sines is smaller, and I have a pair of opposites. Opposite. I don't know, Jace, what do you want? X or Z?
X.
X it is. All right, so law of sines, right? Because I have my opposite, so I'm going to set up sine of X over 18 equals sine of 66.9 over 21, and I'm just going to multiply up the 18, right? And I'll go, okay, 18 times the sine 66.9 divided by 21, and sure enough, I'll get a decimal. Kind of anticipate the decimal, and we'll sine inverse that, right? Sine inverse that answer, and I get about 52 degrees. Okay, so angle X. Okay, so put my 52 in there, and then to find angle Z, that's easy. 180 degrees in a triangle, right? So I'll find the measure of angle. Z will just go 180 minus parentheses 66.9 plus 52. And I get an answer of 61.1 degrees. Okay? Thumbs up on that one? So it's not hard, is it? You just have to use your formulas and you guys are good to go, okay? Alright, we'll do... Alright, the double triangle, huh? Oh good, we have time. Whisk that away. Okay, now, this one's worth basically 7 points. So we've done it a couple of different times. Let's do it again. You're gonna need a protractor, ruler, all that good stuff, which I don't have on me, but I'll get a protractor and ruler. Okay. Protractor, ruler.
There's half one.
I can't find a protractor. Where do my protractors go? No. Still recording. Okay, ready? Let's see if we can do this. Hopefully we'll find enough protractors tomorrow to be able to get us through, huh? So, first of all, the way I'd start this is angle A. So, let me write down what I know. On 6, measure of angle A is equal to 35 degrees. I have little a is 5 centimeters, and little b is 7 centimeters. Okay, so I'm going to draw it. So when I draw this, first thing I'll do is start with angle A. I'm just put a dot, call it A, and that will become angle A when I construct it. Okay, so let's see here. Okay, so I need a 35-degree angle. I'll use my protractor. 35 is right there. Okay, zero it out. 35 degrees. Okay. Now, side B has got to be here somewhere. So if I draw my angle A, here's my angle A at 35. Here's 35. Now, keep in mind that side A, angle A, side A has got to be over here somewhere. Where does it attach? I don't know unless I give it a length. So I'm going to draw little b here of 7. And by doing that, I'll locate where I should put side A. So if I make this 7 centimeters, right there, and I can erase all the excess, okay? So let's put side B here, 7 centimeters. And now I know where to attach side A, which is 5. Now there are 2 places to draw it, here and also inside here. I'm going to do both, but let's do the bigger triangle first. So I'll draw my side B right here, and I'll fit in the 5 right there. Okay, so it will make 2 triangles, okay, because it's the bad triangle. That's little a, which is 5. Okay, now I can label my triangle. I've got A, this has got to be B. I can erase the excess, and angle C, all right? I have a pair of opposites. I do. So if I have a pair of opposites, angle A, side A, I can find a pair of opposites. Angle B, side B, right? Am I going too fast?
A little bit. Yeah.
Okay, I'll slow down for a second. Okay. So I've got it constructed. So I have my opposites. I'm going to find B, angle B, so I'll go sine of B over 7 equals sine of 35 over 5, right? Law of sine is just opposite. It's easy. I'll multiply up the 7, and I'll use my calculator. I'll go 7 times the sine of 35 divided by 5. Get a decimal, right? But of course, we're going to sine inverse that answer, and I get about a 53.4, okay? So angle B is about a 53.4 degrees, okay? 53.4 Of course, angle C is easy, right? Angle C is just 180 degrees in a triangle. So angle C, the measure of angle C is equal to 180 degrees minus the sum of the other two acute angles, 35 plus my 53.4. Use my calculator. 180 minus parentheses, 35 plus 53.4, and I get an answer of about 91.6. Okay, got it. How am I doing? But what if Olivia drew the other? Because you did. You're the only one who drew the other triangle. Nice job. So the other triangle, if I drew the 5 instead of here, it could also be right there. Now it's a pretty skinny little triangle, but there is a triangle right there, okay? All right? Because it does follow the directions. Okay, it really does. And that's my other triangle. Let me tidy this up a little bit. Put my 35 right in there so it looks better. Right, put my 35 in there. So, if we did the directions, 35 degrees, 7, and 5, there is another triangle that's possible, right? So to solve the other triangle, first of all, I have to recognize this is an isosceles triangle, 5 and 5. Because those two sides are both 5 and 5, it makes an isosceles triangle, which means base angles are going to be equal. So this 53.4 is also here, 53.4 degrees. Okay, now, that's not the angle we want. The angle we want is angle B is here. Now, angle B, we're going to shift all the way to there. Okay? And angle B is an obtuse angle, but we know that with 53, an angle B is 180 degrees because it's going to be a straight line. So, to find the other triangle, okay, so that's my small triangle, I'm going to go for the measure of angle B. We'll just go 180 degrees minus my 53.4. Okay, 180 minus 53.4, and I get an answer of about 126.6. Okay.
What was that thing? This 53.
Now, angle C is no longer all of this big angle. Yes, Ashley.
So are we doing, because we didn't solve for side C.
Yeah.
Oh my goodness. I got ahead of myself. Let's do side C first. Side C, sine of, what was that, 91.6? Thanks, Ashley. Equals 5 over the sine of 35. Cross multiply. Wow, I forgot to do that, huh? Yes. Yes. 5 sine of 91.6 divided by sine of 35. Yeah, okay. How about 8.7? Okay. Thanks, Ashley. And I'll go back. I'll go back to the other when you're done, okay? Now, let's go back to this one. Angle C. Angle C is just here. But it's the same thing. It's like 180 degrees in a triangle. So the measure of angle C is 180 minus my 35 plus my 126.6 degrees. Did you already get it? What is it?
18.4.
18.4. I'm going to believe you because you're always right. Okay. I think Johanna. And then we got little c. Then we'll do the exact same way we just did little c, but with little triangle. So little c is this side here. And again, we'll set up our opposites. Am I going too fast? I must set my opposites. So c, and this angle here is an 18.4. So we're going to go little c over the sine of 18.4 equals 5 over the sine of 35, cross multiply. I get an answer of about 2.75. Okay, you need to show work. Okay, if you just measure things with your protractor and your ruler and you draw it really well, no work, no credit. Okay, you got to show work. Okay, what's that?
Push it up.
Oh, yes, yes. Okay, how am I doing? We're getting there. We still have like, what, 15 minutes? We'll get this done. We'll get this done, okay? I have homework for you. It doesn't mean I will give it to you. If I run out of time doing this, then I won't give it to you, okay? All right, moving on. Number 7. Okay, so it's not that hard. You guys should be able to do this. Let me see if I can draw it real well. I've got my templates. Okay. So here's my pentagon. Yeah. Another piece of regular paper? Of course you can. Let me do this real quick, okay? Okay, anybody want to borrow this, I suppose? Ashley? Ashley's going to want to borrow this for sure. Actually, I've got another one here.
Okay, I'll take it over.
Okay, I've got one more here.
I'll take it over actually.
There you go. Okay, I mean, yeah, it's there.
Alright.
Wait, no, bring it over.
Okay.
So a regular pentagon with side lengths of 22. Okay, so 22, 22, 22, 22, 22. Is inscribed in a circle. Find the radius of the circle and the area of that pentagon. What?
This paper, please.
Oh my gosh, Gavin, yes. Here, let me give you a couple of those. My bad. Here you go. Yeah. Okay. So, okay, now this problem's not that hard because there are 5, right? 5 triangles in this pentagon. Let me draw it, okay? And we're only going to look at one, and then we'll multiply by 5, okay? Does that make sense? Yes, Daisy.
You can split it up into 3.
Yes, you can split it up into 3. That's correct. I'm going to do 5, though.
So
Yes.
that they all have equal length.
And they'll all be equal. Yeah, you're totally right. I'm going to stick with 5, and I'm not going to say you're wrong. I'm going to say you're completely correct. How's that for an answer, huh?
I can make 5.
You can live with that? All right. Me too. So let's look at one of these. Nice job, Daisy, seeing that there really are 3. That goes back to a geometry formula. 180 times n minus 2. N minus 2 because there's 3 triangles. You with me on the n minus 2, right? Okay, so now, what do we know? I know this. This side's 22. That would be the radius of the circle. Wouldn't that be the radius right there? Okay, I know that is 72 degrees. Whoa, where did I come from 72? How'd that happen? Well, in a circle at 360 degrees, I'm divided by 5 central angles, right? See the 5 central angles? Central angle, boom, 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 we get 72 degrees, okay? Now, if I need the radius, let's see. I'm going to need more, right? I'm going to need more. Well, I could probably get these 2 angles because those 2 angles have to be equal, correct? So if I go my 180 minus my 72, 180 minus 72, I get 108. And I divide that by 2, right?
54.
And I get 54. So I've got 54 and 54. Okay, now, do we have a pair of opposites? Heck yeah. Now we could also do this with right triangle trig. I'm going to cut it down. We could like slice it right down the middle. And we can use those, but gosh, it's so much easier with law signs. Do you agree with that? Then I got my opposites. So let's set up my opposites. I'll show you what I'm talking about. You can do this one another way. I would just prefer to do it the easy way. What's the easy way? Let's set up our opposites, okay? So I've got opposite, 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 opposite. So to find the radius of the circle, I'm just going to set it up and go R over the sine of 54 equals 22 over the sine of 72, right? My opposites. Side over the sine of its opposite angle. Side over the sine of its opposite angle, okay? I'll multiply that up there. I'll just take the calculator and go, okay, clear 22 times sine of 54, close my parentheses, divide by sine of 54. Nope. This is sine of 72. And I get an answer of about 18.7. So I know the radius is at 18.7. Now the area, well, that's easy. It really is, because I've got my cool formulas that we got. Let's see, where's my cool formulas in here somewhere. Oh, here's my cool formulas. So my area is 1/2 adjacent sine of the angle. Okay, so let's just use right there. And then multiply by 5. You're totally correct. So what I'm going to do is find the area. The triangle, then I'll do it. Daisy said, get the triangle, multiply by 5, right? So the triangle area is equal to 1/2 18.7 times an 18.7 times the sine of 72. Okay, let's go 0.5 times 18.7 times 18.7 times the sine of 72. I get about 166.3 for the triangle. But Daisy said multiply that by 5, because there are 5 triangles. And Daisy, your method of the other 3 triangles would also work, okay? Exact same process. It really is, okay? Times that by 5, you get an answer of about 831.43 centimeters squared. I don't think any kid in my entire career has ever said, really, that's pretty cool. No one's ever seen the 3 triangles. Good job, Daisy. Okay, thumbs up. All right, let's take a boat trip. All right, let's get this last one done, okay?